Hey y'all, Ms. Z here, and today we're going to do our next lesson on dilations. So I'm gonna go ahead and have you get out your notebooks, of course, set up your day for today. Our standard today is the same, 8.G.4. Describe the effect of transformations on 2D figures using coordinates. Okay, of course, we're still working on transformations, and our essential statement is I can dilate a figure with a scale factor of k is less than 1. Okay, so we've done k is greater than 1, and we're moving on to k is less than 1. Unfortunately, this means fractions, and I know how many of you are afraid of fractions, but it's okay. We're going to try to use fractions that will work, if you know what I mean. Okay, so a couple of reminders. The rule that we use is you take your ordered pair x comma y, and that goes to k times x comma k times y. K is the variable that we use for scale factors. It's weird, I know. Let's move on. Okay. So next, actually, let's do this. Let me move this out of the way, and in words, okay, the rule means you multiply your ordered pair by the scale factor. That's all that means, okay, that's in words. And then we're gonna move on to what is a reduction. A reduction means that your pre-image, you're going to have your pre-image, and then using your transformation, you dilate the image, and you're going to get a smaller figure after you dilate when the k is less than 1. Okay, so here we have, I'm going to go ahead and open this up. Here we have our example. Our example states, graph the image of triangle JKL after a dilation with a scale factor of k equals 1/2. Are you guys all afraid? I hope not. Okay, so let's go ahead and do this problem. We have our rule still at the top. Okay, I left the rule up there just so we see what we're doing. And then we have our triangle JKL. Okay, so J is 6, 4. So I'm going to go ahead and start at the origin. 1, 2, 3, 4, 5, 6, and up 4. 1, 2, 3, 4. I'm going to go ahead and plop down J right there. And don't forget to label, please. That's J. Next, we have K. K is -4, 0. So this one's interesting. Okay, so you start at the origin, and then you move left 4. So 1, 2, 3, 4. But then you don't go up or down. So you stay at 0. And that is K. All right. The next one is, oops, do I have 2 J's? That's weird. Don't mind me. That was intentional, okay? Usually at this point, I have one of you say, hey, Ms. Z, hey, why do you have 2 J's there? So I changed that for you, okay? So there we have L, 3, -2. Start at the origin, I go 1, 2, 3, down 2, 1, 2. Okay, here's L. It's an interesting looking triangle. I'm gonna go ahead and find my ruler and draw my triangle JKL. Don't mind that. Nicole is messing around with some toys in the background. No worries. I know you guys miss my stories about Nicole and Michelle, but we don't have time for that, sadly. Maybe next time. Okay, so JKL, there's our triangle. All right, so yesterday was pretty simple because we just took the scale factor and we multiplied the numbers. The same thing applies here. Now the problem is that fraction 1/2, okay? So what I'm going to do is I'm gonna write down the steps and show you what it should look like. So j to j prime, okay, to j prime, we're going to take 6 and multiply it by 1/2. Okay, that's our scale factor. And then we're going to take 4 and multiply it by 1/2, okay, our scale factor. Now, if you think about it, multiplying by 1/2 is really the same thing as dividing by 2. So when I take 6 times 1/2, or 6 divided by 2, I actually get 3. And then 4 times 1/2, or 4 divided by 2, or half of 4, think about it that way, is 2. Okay, so now you're like, well, 1/2 is a pretty easy fraction, Ms. Z. What if I get something weird? Okay, well, let's say it's 1/3. 1/3 is really the same thing as dividing by 3, or taking a third of something. The same thing with 1/4. It's like dividing by 4, or taking a fourth of something. All right? It does get tricky when your scale factor is like 2/3, because then you just take your number and you multiply by 2/3 like you would using the properties of fractions. Okay, so let's move on to k. So k prime, so you have -4 times 1/2, or half of -4 is just -2, and then anything times 0 is always, yes, 0, thank you. And then L prime, uh-oh, this one's weird. Okay, so I'm going to write this one out actually. So I have 3 times 1/2, and then I have -2 times 1/2. That one you guys could probably do. Okay, so 3 times 1/2, or half of 3. Yes, you do get a fraction or a decimal or whatever you want to call it. Okay, half of 3 is 1.5. I'm going to write it as 1.5. I know, kind of weird. Okay, and then half of -2 is just a -1. Don't let negatives or fractions freak you out, please. If you have any questions, feel free to send me a message, okay, comment, or Google Classroom, whatever it is. I know this one is a little tricky with those fractions. So we're going to go ahead and plot these points. J prime is 3, 1, 2, 3, comma 2, 1, 2. This is J prime. Don't forget to label. K prime is -2, comma 0. So you go left 2, but then you stay. So that's K prime. And L prime is 1.5. So you start at the origin, then it's 1.5. Okay, so right in between right here, but you don't plop it down still. You still have to go down 1 right here for L prime. All right, and then we're going to go ahead and take our ruler, or a straight edge, or an index card, or the side of a book, whatever, because you want nice straight lines, or line segments, I should say. Okay, and then, so now, the difference when a scale factor is less than 1, you notice, is your image is actually smaller than your pre-image. All right, and that is a dilation when a scale factor is k is less than 1. Feel free to comment a question or send me one on Google Classroom, whatever it may be.